Welcome to this solution video of paper 1-3 of AS level mathematics, pure math 1. Question number 1. The coefficient of x cube in the expansion of this is 144. So let's write the specific term where we get x cube, right? That's what we want. So x cube will be given by 1 over px. So let's write 1 over px cube. That's how we will get cube, and that's how we start with. Now, the remaining is the second term in binomial expansion. The remaining exponent is given to the second term. So 3 exponents are with 1 over px, so remaining 1 will be with p. And we have to write a coefficient also, which is NCR. N is the greatest exponent we have here for C, and R is one of these two, 3 or 1. Anyone you can write. I'm writing 3. Okay, this is the term which will have x cube. Let's try to expand this. 4c3 is 4, and 1, x and p, all three of them will have this cube. So 1 cube multiplied by x cube divided by p cube. So that's how we get x cube multiplied by p to the power 1, which is just p. So we are focusing on the term itself. Okay, right now we are focusing on the term, not the coefficient. So 4, there is no other number, so 4 will remain 4. 1 cube is 1, so 4 multiplied by 1 is 4, so 1 can be ignored. X cube is x cube. This p and this p cube will cancel out, and we'll be left with only p square at the bottom. Okay, this is the term. What is the coefficient of this term? Coefficient will be, except for x cube, 4 over p square is the coefficient, right? X cube is the variable part. Okay, they said this is equal to 144 and find the value of p, and now we can find the value of p. So let's do cross multiplication. P square goes there, 144 takes its place. So 4 over 144 is equal to p square, and to get p we square both sides. So square root of 4, well, let me do it here, 2. Square root of 144 is 12, and whenever we square root we have to write plus and minus both. So plus and minus equal to p. So 2 and 12 cancel. We get p equal to plus or minus 1 over 6. That is, they are the possible values of p. Question 2. The diagram shows part of a curve with equation, let me write it again, y equal to p sine q theta plus r. Okay, where p, q, r are constants. State the value of p. Obviously later they will ask the value of q and r also. Let me try to explain everything here. So whenever there is a format like this, for a sine or cos graphs, p becomes the amplitude. Q is 360. Is it in degrees? No, it is in radians. So it will be 2 pi over period. And r is the axis. Let me define one by one. Amplitude. Amplitude is the distance between the axis, which is the middle line, and the maximum point. And for amplitude, we use this formula. Whatever is maximum, here this is maximum, which is 1. We subtract minimum from this, which is -5 in this case, right? This is minimum. So if I subtract -5 from 1, I will get this distance from maximum to minimum, this distance, right? And if I have that distance, that becomes amplitude. So maximum minus minimum divided by 2 is your amplitude. So let me substitute the values here. Maximum is 1 minus minimum is -5 divided by 2, which is 1 plus 5, 6 divided by 2, 3. The value of p, which is amplitude, is 3. Let me write it is equal to p. Let's say Q. Q is 2 pi over period. Do we know the period in this case? See, period is between the horizontal distance, the x distance, or in this case theta distance between the two consecutive maxima or minima. But we don't have two consecutive maxima or minimum. So what will we do? We'll see the distance, the horizontal distance between the maximum and minimum. One maximum and minimum we have, right? The horizontal scale here is pi, horizontal scale here is 3 pi. So the distance between them is 2 pi, isn't it? And that's how we find period. So period will be the maximum or minimum for that case. In this case it is minimum, right? At 3 pi we have minimum. Let me write this way. Theta minimum minus theta maximum will give us half the period, not full the period, okay, because we don't have two consecutive maxima or minima. So it will be 3 pi minus pi, which is 2 pi. So period will be 2 times, rather it will be 2 times this, right, because we don't have full maximum minimum. So 2 pi multiplied by 2, which is 4 pi. So now we want to find Q. Q is 2 pi divided by period. Period is 4 pi for us. So 2 pi, this is Q, divided by period, which is half. Pi cancel, 2 over 4 is half. That is the value of Q. Let's see R. R is the axis. Axis is the exactly middle point, middle line of the maximum, between maximum and minimum. So basically average of the two. So for amplitude it was maximum minus minimum. For R axis it will be maximum plus minimum divided by 2, basically average of maximum minimum, which is 1 plus negative 5 divided by 2, which is negative 4 divided by 2, negative 2. Actually negative 2 is not is the value of R, but it is not axis. Axis is the line y equal to negative 2. This is axis, but since they are asking just R, minus 2 is R. So we got Q, R and P, and let's confirm if the B and C part they are asking us to find P and R. And you can see that B and C part both have they're asking us Q and R. So let's move on to 3 now. An arithmetic progression has first term as 4. So A1, which is also known as A, is 4. And common difference is just D. The sum of the first n terms in the progression is 5863. Okay, so sum of n terms, the formula is n over 2 2a plus n minus 1 d, and they're saying that it is equal to 5863. Show that this expression is true. Okay, so Sn is given to us 5863. So let's write 5863 equal to n over 2 times a is 4, plus n minus 1 d. So let's get rid of this 2 first, multiply both sides by 2 so that this 2 is gone, this 2 and this 2 cancel out. So 2 times 5863 will be 11726, yeah, the same number they are giving here. Okay, they want n as a denominator, so let's get rid of this n by dividing whole of it by n, and on the left side as well, so that n and n cancel out. So we are left with n equal to, what is left here, 2 times 4, 8 plus n minus 1 d. Okay, exactly, and this 8 again will subtract 8 from here and will subtract 8 from this also, so that 8 is also gone. So we are left with n minus 1 d equal to 11726 over n minus 8. That's what they're asking us to prove. And here is the B part. Given that the nth term is 139, okay, so we just got in previous part that n minus 1 d is equal to 11726 over n minus 8. Yes? Alright. Nth term is 139. That means an is 139. Find the values of n and d. So for an, the formula is first term plus n minus 1 d, right? So n minus 1 d is known to us now, which is equivalent to this one. So in place of this part, we can use the right hand part, this one. So 139 equal to a, the first term was 4, plus n minus 1d is 11726 over n minus 8. So 4 minus 8 is negative 4. So 139 equal to negative 4 plus 11726 over n. So to get rid of this negative 4 to the left side, we will add 4 here and we will add 4 to the left side also. So they're gone. 143 equal to 11726 over n. And now, just like question number 1, we will interchange their places. N will be equal to 11726 over 143 is equal to 82. And we have to find d as well. So we can use this relationship here, which is n minus 1. N is 82 now. So 82 minus 1 d is equal to 11726 over n. 82 minus 8. So 82 minus 1 is 81d equal to 11726 over 82. 11,726 over 82 will be 143 because that's what we got by division here. So 143 minus 8. So 81d equal to 135 and divide both sides by 81. So d is equal to 27 times 3, 27 times 5, 5 over 3, that is d. It's unusual to have d as a fraction, but here they have written here d as a fraction. In the question itself, they've confirmed it will be a fraction, and that's why it is a fraction. Question number 4a. The curve with the equation y equal to x square plus 2x minus 5 is translated by negative 1, 3. That means the x component is translated to the left by negative 1 and y is translated up by 3. What we mean is this: if this is the curve will go to the left by negative 1 x component, and this will go up by 3. That means if whatever is vertex will go left by 1 and then up by 3, and the new position will be somewhere here. Okay. Now find the equation of the translated curve. Okay, new curve, giving your answer in the form of this again. Alright. So first we should know what is the format of every graph in a translation. Not only this quadratic, any general graph. It should be fx or y equal to a f, let's call it k, x minus b plus c. This is the format of every function, and which tells us how it is transformed from the basic function. For example, here the basic function here is quadratic, which is y equal to x square. So we want to know how much it is already translated, and we will know that by transforming this main equation into the completing the square method, and that will give us the original translation first. We'll talk about minus 1, 3 later. Okay, so y equal to x square plus 2x minus 5. This is the one we want to convert it into completing the square method. So I will do it. X square plus 2x, then leave some space, negative 5 Okay. Now I add square of half of this number, which is 2 here. So what is half of 2? 1. So 1 square will be added and same will be subtracted. Right? There is no coefficient here. So whatever is the square, we subtract that outside. So it comes out to be the square root of the first one, then sign plus, and then square root of this one, which is 1, square outside minus 6. This is the translated form of the equation they've given us, which means from the original function there has been nothing vertical translation or vertical stretch or compression. There is no horizontal k, there is no k, there is no horizontal stretch or compression, but there is a translation of -1 already here. Yeah, because there is a negative sign here, so because it's positive, so we take it as -1, and there is a translation of -6, means down 6 in y direction. This is in x direction, this is in y direction. This is the original function. Now we have to translate this further by -1 for x and 3 for y. That's what we're going to do now. So y equal to x plus 1 is the original one, minus, then we have to do -1. Yeah, because this minus in place of x, we are writing x plus 1 because this is the original one for us, and we are translating it further by -1 with the help of this negative. And then we had -6 here. Y translation, the vertical translation is 3, so we will add 3 outside. So to the whole function we have added 3, but x we have actually added 1 here. So what will that become? X, I forgot to write a square here, x plus 2, yeah, plus 1, 2, square minus 3. And that will give us the new format, y equal to x square plus 4x plus 4. I hope you understand this expansion, a square plus b square plus 2ab. This is the expansion of this. So I've done a square plus b square plus 2ab, and we had -3 outside. So we are left with y equal to x square plus 4x plus 1. This is the translated version of the original, the new function to the further one with -1, 3. Okay. Now what do we have next? The curve with equation x square plus 2x minus 5 is transformed. Is it the same? Yeah, it's the same. It's transformed to a curve. Okay, this one. Describe fully the single transformation. Okay, that will create little trouble for us because they're saying single transformation. If there are multiples, we could have done very easily like we did in previous part, but it's single one they want. So we have to see if we can convert them. Okay. So -5 is here and -5 is here. So let's not touch -5 and -5. So x square plus 2x minus 5. We already had a transformation for this. X, y equal to x plus 1 square minus 6. Now we want to convert this also, but there should be only one transformation. That means -5. Let's keep -5 here, because this is already a transformation. This is -6, this is -5, but maybe the bracket will help us. Equal to. We don't want anything else. So let's do this 2x square. Okay, so it is already transformed by doubled. Okay, then 2 times 2x, right? This 4x, this is this 4x here, so we write 2 times this 2x times only 1 is possibility here. So what should I add to make it a perfect square? I should add 1 square because I have 1 here, so I have to square that one here. Alright, so what do we get? We get square root of this, which is 2x, then square root of this, which is 1, and there's a plus here, and it is fulfilling 2ab. This is fulfilling that. Okay, so I added this 1 from my side. I have to subtract that 1 here also. Okay, we got the similar thing. Yeah, 2x plus 1 square minus 6. Alright, so now compare these two. This is x plus 1, this is 2x plus 1. That means x has been doubled. X is doubled. Okay, minus 6 is minus 6 square. Everything else matches. 1 is 1. So this is the only one transformation that x has been doubled. So when something is doubled in x direction, we say that there is a horizontal stretch, right? Stretch by a factor of reciprocal of whatever is there, half. Question 5, A part, solve the equation 6 square root y plus 2 over square root y minus 7 equals to 0. Since square root y is little complicated, let's assume let square root y is equal to some alphabet m. So our equation becomes 6m plus 2 over m minus 7 equals to 0. And we should get rid of this denominator, otherwise it will be difficult to solve this. So multiply the whole equation by m. So m multiplied by 6m is 6m square. 2 over m multiplied by m and m will get cancelled out. So plus 2 minus 7 times m equal to 0. Let's rearrange it. Okay, minus 7m plus 2. Now you can use your calculator for finding the values of m, but I'm using the factoring method. 6 times 2 is 12. 3 times 4 is also 12. So 6m square minus 3m minus 4m plus 2 equal to 0. The midterm has been broken into two parts so that I can take something common from these two, which is 3m. So it will be 2m minus 1 from these two, and these two I can have negative 2 common, so we'll be left with 2m minus 1 again. So 2m minus 1 is in both, 2m minus 1, and we'll be left with 3m minus 2 from both the terms. So since their multiplication is equal to 0, that means either this is equal to 0 or this is equal to 0, and we equate both of them equal to 0. So it gives us 2m equal to 1, where m is half, and here 3m equal to 2, m is 2 over 3. But m was our assumption, actual variable was y. So let's go back to square root y equal to 1 over 2, that's the first answer, and second answer is square root y equal to 2 over 3. To get y, we'll square both sides. So here we get y equal to 1 over 4 and y equal to 4 over 9. These are the two solutions, and there is no special filtration, so these are the answers. Okay, so let's move on to the B part it has, which is this. Exactly same equation, but in place of y we have tan x. That means the solutions from the previous part can be used here. Tan x equal to 1 over 4 and tan x equal to 4 over 9. So x will be tan inverse 1/4. Luckily it is positive. So similarly here it is also positive, tan inverse 4 over 9. But our answers should be from 0 to 316. So we can't have one answer that just put this in a calculator, you get the answer. No, we have to get two answers. So if we talk about these quadrants, tan is positive in third quadrant and first quadrant. So first and third quadrant, and just put tan inverse 1/4 in your calculator, you will get an acute angle and use that one. So if I use my calculator, I get 23.97. So 24, we can say 24 degrees here and 24 degrees here. So the first answer will be from 0, always from 0 to this line, first line, which is 24 itself. Second line will be from 0 again till this line. So here we are crossing 180. So it will be 180 plus 24, which is 204 degrees. And here x again same positive, so that means again first and fourth quadrant, 4/9 tan inverse. I get around 14 degrees this one. So 14 degrees here as well. So our third answer will be 14 degrees again from 0, and fourth will be similarly in third quadrant, 180 plus 14 equal to 194 degrees. These are the four solutions of this equation. Question 6. The function f is defined as this one, okay? For x is less than 3 only, not even equal to 3, okay? Express fx in the form of, okay, completing the square, which we have done earlier. So let's do it. So since they wanted 2 outside, so we'll take 2 out of these first 2 terms. So 2, and in first term only x square is left. In second term it will be 8x left. And then we'll have 23 outside. Now we have to add the half, square of the half of this. Square of half of 8 will be 4 square. Right? So I added 16 here, but effectively it will be 32 I added because of this 2. 16 times 2, 32 I added from nowhere. I have to compensate that outside. Okay? And now it will be 2 square root of this, which is x, square root of this, which is 4, and the sign from the middle one, square minus 9. So express fx in the form of this has been done. This is fx. So a, since it is plus here, we have to take the sign whatever is here. So a is negative 4. B is negative 9. And we have done this one. Let me take the other one here, the second part, which is the second B and C part. Let's do the B part first. So they're saying find the range of f. Whenever you are asked about the range, draw the graph. That will help you the best. Okay? So let's draw the graph of this one. So whenever we look at the graph, we look at the vertex form, because this is also called vertex form. Completing this square format is also called vertex form because it gives you vertex straight away. So vertex in this case will be the negative of this, which is positive 4. That is the x-coordinate of the vertex. But there is no change in negative 9. This is where your vertex will be. So let me draw it better way. Not good. So okay. 4, positive 4, suppose positive 4 is here, negative 9 is here. This is the vertex, negative 4, 9. Now, the 2, which is the coefficient in leading coefficient, is positive. That means it will open up. So it will be somewhat like this. I'm just drawing it, okay? It is not, it may not be exactly like this. But I'm interested in vertex. That's how it will look like. Alright. Now we have to write the range. Range could have been that the lowest value of y is 9. Range is about 9. So range is about y value, correct? And minus 9 is the lowest value. But there is a problem. They said x is less than 3. That means if this is 4, isn't it? Because the vertex is here, positive 4. That means 3 will be somewhere here. And your graph will be only for less than 3. Not even for 3. That means I have to erase the part which is more than 3. Gone. So now the range cannot be more than negative 9. It has to be more than whatever is the y value of this one. The y value of this 3 will give us the limit above which we have the range. Yes? So let's find what is the y coordinate of 3. So if x is 3, what is y? This is what we have to find out now. So let's use the vertex form itself. Okay. So fx is y. Then we have 2x minus 4. X is 3 now for us. Square minus 9. So which is 3 minus 4 is negative 1. Square minus 9. Negative 1 square will be positive 1. Positive 1 times 2 will be positive 2. 2 minus 9, which is negative 7. That means this y coordinate of the limit here is negative 7. It is not equal, okay? That means it is less, it is above negative 7. It is not even 7 because the limit is x is less than 3. It is not equal to 3. So our range will be fx, or if you want to write y, you can write y also, or y is greater than negative 7. That becomes the range. Okay. C part, find an expression for f inverse x. Whenever they ask you to find inverse of a function, always, a quadratic function that is, always convert it to vertex form first. And here in this question they have already asked you, most of the times they ask you to convert to vertex form first so that you can easily find the inverse, and that will help us to find inverse. You cannot find inverse from the normal standard form of a quadratic function. So let's start with the vertex form. Fx equal to 2x minus 4 square minus 9. This was the one. This function fx is nothing but y. So we can also write this as this format. Now to find the inverse, we exchange the places of x and y. That means this y becomes x and this x becomes y. Right? Now, to get rid of this negative 9, we will add plus 9 here so that on both sides, so that this negative 9 is gone, because our target is to isolate this y. Okay, second step should be to get rid of this 2. Divide this side by 2. We divide the other side also by 2, so that 2 and 2 cancel out, and we are left with x plus 9 over 2 equal to y minus 4 square. Okay, now x plus 9 over 2 is there, but this square will not let y to be isolated, so we will square root both sides. So we have to square root here as well as here, and when we square root this side, we have to write plus and minus both. This square cancels with this square root, and we are left with 2x plus 9 over 2 square root plus or minus y minus 4. Okay, now this minus 4 also has to go, but there is a problem. We got, if you remember, the condition given earlier was x is less than 3 for this function, right? That means the range for the inverse will be y is less than 3. That means we can have here less than 3, any number less than 3, which can be 2, 1, 0, or even the decimals in between, right? So that will give us a negative 4 if I take y equal to say 2. So 2 minus 4 is negative 2, right? And we have plus and minus both options here. So we cannot have a positive in any case if y is less than 3. So that means the positive has to be ignored and negative has to be kept. So it will be negative square root x plus 9 over 2 equal to y minus 4. And this negative 4 can be removed now by adding 4 to the both sides. So we are left with y equal to this, which we can rearrange as f inverse x. This y is nothing but f inverse x, which is 4 minus square root x plus 9 over 2. This is the inverse function. Okay, what is next? There is another function, g, which is 2x plus 4, a linear function, okay? And x is less than negative 1, alright. So find this and simplify an expression for f gx. That means gx is inside f. We can write it as f g of x. So let's replace gx by its value, which will be f 2x plus 4. So if you remember, fx was 2 outside, x minus 4 square minus 9. As far as I remember, let me confirm. X minus 4 square minus 9. Yeah, that was the one. Okay. So now we have to substitute this value of gx inside this one. So we will write f 2x plus 4 will be 2. In place of this x, we will write 2x plus 4. 2x plus 4 minus 4 square minus 9. Plus 4 and minus 4 cancel out. So we are left with 2x square minus 9, which is 2, and this square will apply to 2 and x both, which will be 4x square minus 9, and that's why it is 8x square minus 9. That is FGX. Question 7. We've been given a circle here, then x and y axis, and they're saying the diagram shows the circle with this equation with center at C. Point B has coordinates 0, 2, and the line segment BC intersects the circle at P. We can see it here. Alright. So what do we want? Find the equation of BC. Alright. So BC is decreasing, right? It's a line going down. That means we'll have a negative gradient. That's what we should know. Alright. So from this equation of the circle, we can find the coordinates of the center, which will be x minus 2. That means 2 is the x coordinate, and negative 4, y minus negative 4. We can write it y minus minus 4, right? So that is negative 4 is the y coordinate. So we have both the coordinates of C and B both. That means we can find the gradient of BC now. Gradient of BC. And why do we need gradient? Because we know the equation of a line is y minus y1 equal to m x minus x1, and m is the gradient, right? y1 and x1 are any coordinates on the lines. We can use 2 minus 4 or 0, 2, anyone, but m is the one we need, and that's why I'm finding gradient with the help of these 2 points, which is y2 minus y1 over x2 minus x1, right? So let's take negative 4 as y2 minus 2 on top, and 2 minus 0, which is negative 6 over 2 and negative 3, and as expected the gradient is negative. Now we can put these values here in this equation. Y and x are random coordinates on the whole line, so we don't have to replace them, but y1 will be the coordinate of any one. Let's say this negative 4 is y1, so it will become negative 4 equal to m we have now negative 3, and x minus what is the x coordinate? 2 for negative 4. So we get y plus 4 equal to negative 3x and plus 6. Let's bring these to the left side, and what do we get? Y plus 4 plus 3x minus 6 equal to 0. So it will be 3x plus y minus 2 equal to 0. This is the equation of the line BC. Okay. Now there's one more part, which is B part, and it is hence find the coordinates of P, okay, which is the point of intersection of the two. Okay, so if I look at the equation once again, let me write the equation x minus 2, okay, square plus y plus 4 square equal to 20. So if I isolate y from here, let's isolate it now. So it will become y equal to negative 3x plus 2, right? And since this point P is the point of intersection of the two, the circle and the line, this y and this y have to be same because we are concerned about the point P. So let's substitute it here. So it will become x minus 2 square plus negative 3x plus 2 plus 4 square equal to 20. Now we have only one variable x and we can get the coordinates of P. It will be x square plus minus 2 square minus 2 times, okay. Let's use a minus b identity here, a minus b whole square, which is a square plus b square minus 2ab. So that's what we're going to do here, a square plus b square minus 2ab. Okay, we don't take care of the negative because in formula also negative has been taken care of, so we ignore it here. Now this will become minus 3x, let me do it here, minus 3x plus 6, right, square. So we will expand that as well. So let's write it as 6 minus 3x square. So again, a square plus b square minus 2 times a b equal to 20. Okay, so x square and 9x square. This is 9x square, right? 3 is also squared, so it will be 10x squared. And then we have 2 square is 4, 6 square is 36. So 4 plus 36 will be 40. This is negative 4x. This will be 12 times 3, negative 36. Yeah, x. So negative 4 and negative 36, negative 40x equal to 20. And now let's bring this 20 also to the left side. What do we get here? 10x square minus 40x, and 40 minus 20 will be positive 20 equal to 0. Divide whole equation by 10 to simplify this so that the calculations are smaller. So we get x square minus 4x plus 2 equal to 0. And factoring will not help in this, so we will use the quadratic formula. Negative b, we have 1 as a, negative 4 as b, and 2 as c. So negative b plus minus b square minus 4ac over 2 times a. So what will that be? 4 plus minus 16 minus 8 over 2. So what do we get? 4 plus minus square root 8 over 2. Square root 8 can be written as 4 plus minus 2 square root 2. If you think that this is time consuming, you can straight away use your calculator. By some of the calculators are capable of giving you roots straight away. So now this 2 can be cancelled with both of them above. So 2 and 1. So we are left with 2 plus minus square root 2. This is the value of x, but there are two of them. And obviously, if I let me change the color. If I extend this line further, this will be one value of x and this will be the second value of x. But if you look carefully, this x value at p will be smaller than this. So whichever is smaller in these two, 2 plus square root 2 is 1, 2 minus square root 2 will be 1. Which one do you think will be the smaller of the two? Obviously this one, because here we are subtracting something from 2, here we are adding something to 2. That means this is this second point which we don't want. This is the one which will be the x coordinate of p. So now we have to find y coordinate, and for y coordinate let's use the simpler one, which is a line. Let's use the line. So y equal to negative 3x, x is now 2 minus square root 2 plus 2. So what do we get here? Negative 6 plus 3 square root 2 plus 2. So negative 6 plus 2 is negative 4. So we get square root 3 square root 2 minus 4 is the y coordinate. So we got the coordinates of P now. Finally 2 minus square root 2 was the x coordinate, and 3 square root 2 negative 4 is the y coordinate. This is our answer. Question 8. The diagram shows a curve with the equation this. Let me rewrite, may not be clear here. So y equal to x to the power half plus 4x to the power negative half. The line y equal to 5, this is y equal to 5 line. Okay, intersects the curve at A. We can see that 1, 5 is the coordinate of A. And B, 16, 5. This one. Find the equation of the tangent to the curve at point A. Tangent to the curve will be something like this. This will be the tangent at A. And we have to find the equation of this tangent. Tangent is a line. So again, we'll use the same equation of line we used in previous question. Y minus y1 equal to mx minus x1, where x1, y1 are the coordinates of any point on the line, and I'll take 1, 5, which is given to us. So y minus 5 equal to m, we'll find out x minus 1. Now for m, we have to differentiate this to get m, because m is the gradient of the tangent, and dy over dx is also the gradient of tangent. So this is m. So we just have to differentiate this one. So half comes in front, becomes coefficient, and the exponent goes down by 1. Similarly, 4 times negative half comes in front and it goes down by 1. So what do we get? Half x to the power minus half, and 2 and 4 can cancel. So negative 2x to the power minus half minus 1, negative 3 over 2. Right? This is general m. But we want m at when x is 1. So we substitute this x equal to 1. M at x equal to 1 will be half 1 to the power negative half minus 2, 1 to the power negative 3 over 2. 1 to the power anything is 1, so don't even look at the exponents, just write half here and minus 2 here. We get what? Minus 3 over 2. And that's our gradient here, minus 3 over 2. And now let's cross multiply to get a simpler equation. 2 will multiply with whole of it. So 2 times y minus 5 equal to minus 3x plus, rather let's keep it in bracket. Okay. Now this, if we open up 2y minus 10, and we'll get minus 3x plus 3. And if I bring everything to the left side, we get what? 3x plus 2y minus 10, and then it will be minus 3 minus 13 equal to 0. This is the equation. They have not said any format, so this is good. Let's go to the next one, which is this one. Calculate the area of the shaded region. Okay, so I'll have to look at the original question. Okay, this is the one, and we have to find the area of this one. Okay. So basically this is the shaded area. You can see just a small area. My plan is that I will find the area of this rectangle first. Yes, this is rectangle is okay. From 1 to 16, the rectangle's length is 15 units. Height is 5. They have given y equal to 5. So 5 is the height. So we get the area of the rectangle. That is the plan, which is 15 times 5 equal to 75 units. Now the difficult part will be to find the area of this area under the curve, which is white, which is not shaded, so we have to remove this area, and this area we'll find by integration. So let's integrate our main equation, which is y equal to x to the power half plus 4. Okay, so area under curve will be integration of x to the power half plus 4 x to the power negative half dx applied to whole of it. Okay, so to integrate, we'll add 1 to the exponent and divide by the same exponent, new exponent we got. Okay, plus 4 is a constant, don't touch it. The exponent goes up by 1 and divides by the same exponent again, and plus c. And this is from where to where? Let's go back to our drawing. From this is 1, this line is 1, and this line is 16. So 1 to 16, that's what we want to find out. So okay, we'll go from here. Okay, so x to the power 3 over 2, yeah, over 3 over 2. So I will add just 3 here and 2 on top. Denominator of a denominator is numerator, plus 4x to the power positive half over 1 over 2. So this multiplies here, plus c, and from 1 to 16. Okay, so let's put here, substitute 16 first. X to the power 3 over 2 over 3 plus 8 x to the, not x, we have 16 now. 16 to the power half over 1, no need to write, plus c. When I substituted 16, now I have to substitute 1. 2, 1 to the power 3 over 2 over 3 plus 8, 1 to the power half plus c. C and c will cancel out because of this negative in between. So we are just dealing with numbers now. I didn't write 16 here. I'll write 16. So 16 square root is 4 to the power 3, 64. So 2 times 64 over 3 plus 16 square root. Power half means square root 4. 8 times 4 is 32 minus 1 to the power anything is 1. So 2 over 3 minus, because of this minus, this 8 will also be negative. 34 minus 8 is 24. This is 128 minus 2, 126 over 3. And we have plus in between. That will be 42 plus 24 will be 66 units square. And earlier we had the area 75 units square. Yeah, this was the area 75 units square. We will use that one now. So our finally the area under the curve, not under the curve, it's a shaded area now. So equal to 75 minus 66 equal to 9 units square. Next question number 9. A and B part both are there. First they are asking perimeter and then they are asking the area of the shaded region. In this drawing all details are here. So let me find the perimeter first. So for perimeter we need to know this side, which is known to us, 6 centimeter. This side not known to us, but if we find this whole radius of the sector, we'll subtract this 6 from that and we'll find this one. And for this arc, because arc is radius times the base angle at the center, we need again radius, because this angle will be found out with the help of 1.8. So in both cases we need to know the radius for this line as well as this line. So let me find the radius first and then we will find them one by one. Okay. So to find radius, If I find the line CA, that is the radius. So let me call this B. This is capital B, so let me call it B opposite to it. This is C, so let me call it C. And because this is A, this will be A side. And I will use cosine rule here. Cosine rule says if I want to find B square, it will be A square plus C square minus 2AC cos B. So the angle and the alphabet must match on these two, and B we need to find out, right? So that means B will be square root A square plus C square minus 2AC cos B. And I will put the whole thing together in my calculator by first substituting A is 6, C is 6, minus 2 times A, C, cos, and B is this 1.8. We will use 1.8 here. So just put this carefully in your calculator and you'll get what is the radius of this sector. And what I got was 9.4, approximately 9.4. It was 9.3999, so 9.4 centimeters. That means dB is known to us now, 9.4 dB. 9.4 minus 6, we subtract this 6, so we'll get dB, which is 3.4 centimeters. So we have 3.4 centimeter here. Now 6 is already with us, arc is left. We know that arc is r multiplied by theta. R is known to us, radius is known to us now, 3.4. Theta is to be found out, which is this theta, not 1.8, because this is the angle at the center A. They said center is A. So since this is 6, this is 6, this is isosceles triangle, that means base angles this and this will be same. Let's call them x, right? So we can say here, let me do it here or here only. X plus 1.8 equal to total 180, but this is radians, we will use pi. So 2x equal to pi minus 1.8 and x equal to pi minus 1.8 over 2. That comes out to be 0.67079. 0.670, let me write 8 here. So 4 digits we can round off. So we know theta as well as r now. We can find the length arc DC. Will be r, we just got it, 9.4 times, and angle in radians is 6708. Now we'll find the perimeter. We're doing part A. Okay, so perimeter will be 6 plus 3.4, which is again radius, plus 9.4 times 0.6708. So when we put this in our calculator, we get 15.70. 15.7, three significant figures. Centimeter. This is the perimeter. Let's talk about the B part, which asks about the area of the shaded part. Now the plan for area will be that I will find the area of the whole sector, and then I will subtract this white part, which is a triangle, isosceles triangle, from it, and I will find the area of the shaded part. Okay, so first we have to find area of the sector is half r square theta, and which will be half radius of this sector. Now we know it is 9.4. We found it earlier, times, now we know the base angle also at the center, which is 0.6708. Then the area of the triangle will be half AB sine C, where C is the angle between A and B. That's how we find the area of a triangle. So it will be half. And for me, A and B sides will be A and C, these two sides, because we know the angle between them. So, or we could have used the other one also, because we know this is also at 9.4, but this is exactly 6, though it's better. 9.4 is little rounded off, so I would prefer that one. So half 6 times 6, and the angle between them is 1.8. So now the area of the shaded region will be area of the sector, which is half 9.4 square times 0.6708 minus, this can cancel, 318 sine 1.8. Just subtract and we get our answer. Let me use my calculator for this. By the time I do this, I would request you to subscribe to my channel so that I make many more such videos for you. Like this video, share with your friends to spread this knowledge among others too. Thank you very much. My answer comes out to be 12.1 units square. This is the answer of B part. Let's go to question number 10. The function f is defined as this, okay? 4x plus 2 to the power minus 2, x is greater than negative half. Okay, find, this is a different kind of question, okay? From 1 to infinity, okay? Fx, so fx I will write here 4x plus 2 to the power minus 2 dx. Okay, so since it's a linear function with an exponent, so we can simply integrate it straightforwardly. For that, what will we do? 4x plus 2, its exponent will go up by 1, and we will divide by the same exponent, which is minus 2 plus 1. But further we have to divide this whole thing by the differentiation of what is the base. Differentiation of 4x plus 2 will be just 4, so we'll divide by 4. This is the integration. This infinity part may challenge us, but we'll go there one by one. Let's simplify this one first. So it will be 4x plus 2 to the power minus 1 over 4 times, and this is negative 1, negative 4, plus c from 1 till infinity. Okay, now this is negative 1 power, let's make it positive. So I'll take minus 1 over 4x plus 2. This is what we can write, plus c from 1 to infinity. Now from here onwards, be very careful how we are going to do this. We'll substitute infinity and 1 in this as usual first. So let's do it. Minus 1 over 4 times infinity plus 2 plus c minus 1 over 4 times 1 plus 2 plus c. First thing first, cancel c's because they are of no use. Let's do this one. Open up this one here. Minus 1 over, okay, 4 times infinity. Infinity is a very high number, millions, billions, trillions, and even if you want power 100. Alright, that means this whole thing will be infinity, isn't it? 4 times infinity will be even bigger number, and plus 2 will be infinity again. So 4 times infinity, this is what it is going to be, right? Plus this minus and this minus, it will be 1 over, that will be simpler calculation, 4 times 1 is 4 plus 2 is 6, and 6 times 4 is 20. Okay, let's write 6 first. Okay, now 4 times infinity is again infinity, even 4 times that infinity will be even bigger number. That means very, very high number. 1 over infinity you can write plus 1 over 24. Okay, and now this 1 over infinity, a number say 1 is divided by a number like this. An infinity which has no limit. Does it make sense? It will be what? 0.00000 and very small number. Let me select this and delete just to exaggerate the things, to make you understand why I will make it equal to 0. So this is 0 plus 1 over 24, and that's why we get 1 over 24 as the final answer. The B part says a point is moving along a curve y equal to fx. Y equal to fx was 4x plus 2 to the power minus 2x is greater than negative half. This was fx in part A. In such a way that it passes through a point, its y coordinate is decreasing at the rate of k units per second. That means it is decreasing like this. So suppose the curve is like this, its y coordinate is decreasing and x coordinate is increasing. Yeah, so if x is in this direction, y is in this direction, that means it is decreasing. Okay, at the rate of k units, same units per second. Per second, there is time involved in this one. Okay, find the coordinates of A. So since they are talking about the rate of change increasing and decreasing, let's differentiate it first. So dy over dx equal to, this negative 2 will come in front, 4x plus 2, and then the exponent goes down by 1, which is negative 3. Minus 2 minus 1 will be negative 3. Further, we multiply by the differentiation of what is inside. Differentiation of 4x plus 2 is 4. So what do we get? Minus 8, 4x plus 2 to the power minus 3. And dy over dx. Since they have mentioned the rate of change per second, that means time has to be involved in this. And how can we involve time in both? Divide numerator by dt, denominator by dt, and this becomes the rate of change in y, rate of change in x. Since the change is very small, we can also write delta x over delta t over delta y over delta t and delta x over delta t. Okay, is equal to negative 8 over 4x plus 2 cube. Alright, now they have said that this small change in y is negative k, decreasing at k units per second. That means this one is negative k. And x is increasing at k units per second, that means positive k, is equal to negative 8 over 4x plus 2 cube. K and k will cancel, so it will be negative 1 on this side. Let's cross multiply. So negative 1 times 4x plus 2 to the power 3 is equal to negative 8. Both sides are negative, so we can cancel negative sign. And let's cube root also, so that we get rid of cube. So cube root and cube cancel out, so we are left with just 4x plus 2 equal to, cube root of 8 is 2, and let's complete here. 4x equal to 2 minus 2, 4x is 0, so x will also be 0. So the x coordinate of that point, that specific point, is 0. We have to find y coordinate, so we'll use the main function, which was this one. 0 is greater than negative half? Yes, it is. So we can find y coordinate now. Y equal to 4 times 0 plus 2 to the power negative 2. This is 0. So 2 to the power negative 2, it will be 1 over 2 square, 1 over 4. So the coordinates of that point, specific point A, are 0, 1/4. Let's move on to question 11, which says the point P lies on the line y equal to mx plus c. Okay, and m and c are positive constants. So what does that mean? M, that means gradient. M is gradient, right? Is positive, and c is y-intercept. is also positive. It means if I draw it, C will be somewhere here, y-intercept, and gradient has to be positive. That means it will be increasing from left to right. This is y equal to mx plus c. A curve has equation y equal to minus m over x. Okay. There is a single point P on the curve such that the straight line is tangent to the curve. So suppose the curve is here, somewhere here. And there is only one point P where this curve y equal to negative m over x is having a tangent as this line, y equal to mx plus c. Okay. Find the coordinates of P, giving you a y coordinate in terms of m. That means x has to be a number. Okay. So we know that dy over dx of a curve, that means differentiation of a curve, is nothing but the gradient of tangent. Right? So since the equation is y equal to mx plus c for the tangent, this is the gradient. That means differentiation of the curve will be equal to this m. So let's differentiate the curve. Y dy over dx of y equal to, let me write here, y equal to m over minus m over x. We can write this as negative m x to the power minus 1, and this is what we have to differentiate now. This minus 1 comes in front, and after this negative, and x to the power will go down by 1, which will be minus 1 minus 2, and m remains m. So m is here. So it will be negative and negative positive 1m over x square. This is what we can write it. To make this positive, this exponent, we just reciprocate it. Okay. This is the gradient of the tangent at the point, a specific point on the curve. But that specific point also has the gradient m. That means m over x square will be equal to m. So we can cancel this m and m, which is 1, and cross multiply. So, or reciprocate this. I reciprocate this x square equal to, if I reciprocate 1, it is again 1. So x equal to plus minus 1 if I square root both sides, right? But they have specifically said that P is the only point where it is the tangent. That means plus or minus one of them we have to filter out. They have said that m and c are positive, but nothing about x, right? Though we can see it looks like in negative zone, but we can't say for sure. Maybe the curve was something like this. Maybe here. So x is positive. So we have to reject one of them, but let's see how can we do that. Let's see where does this y coordinate satisfies these two situations. So let me write this one first. Y equal to minus m over x. So minus m over positive 1. Let's do when x is positive 1. Okay, I have to reject one of them, so I have to look at this. So y is negative m in this case. Let's put it here in the equation of the line. So minus m, which is the y value now from the curve, equal to m. We know x is a positive 1 in this case, plus c. So minus m, and m times 1 is also m. It comes to the left side, minus m equal to c. Negative 2m equal to c. They have given that m is positive, c is positive, but this situation will not work because this is negative 2. If m is positive, it will make c negative. That means m is when m is positive, more than 0, c is less than 0, negative, which is a wrong situation because that's what they're saying. No, that means x equal to minus 1 is the right answer, but we have to again confirm it. Let's say when x equal to minus 1, and again use y equal to minus m over minus 1 this time. So this cancels out, so y equal to m. Now let's verify with the equation of line. Y equal to mx plus c. So m equal to mx plus c. So this is m and this is minus m. When it comes to the left becomes m equal to c 2m, and that works when m is positive. If this is positive, 2 times that positive number, c will also be positive. So yes, x is negative 1. This is the x coordinate of p. So let's write it here, negative 1. But what was the question? Find the coordinate of p giving your y coordinate in terms of m. So we have to find y coordinate. So we can use either this equation or this equation. Since this has c extra, we don't know the value of c. Let's use the equation of the curve. So it will be y, we already know it, y equal to m. So m is the y coordinate. We already found it here. Okay, let's go to the next question, which is the b part of the same. The normal to the curve p. Okay, curve was, let me write the equation of the curve, y equal to negative m over x. So the normal to the curve. So if this was the curve, this will be the normal at p. Okay, intersects the curve again. So that means if curve is going this way, it intersects that same curve at q. Find the coordinates of q in terms of m. Alright, so we know that this is the tangent whose equation is y equal to mx plus c, and the coordinates of this came out to be negative 1 m. Okay, so the gradient of tangent was m. So the gradient of normal will be negative reciprocal of this, which is negative 1 over m. To find the coordinates of q, we should know the equation of the normal. So we have to write equation of the normal. At what point? Negative 1 m. So equation of the normal, we write y minus y1 equal to not m, because the new gradient is negative 1 over m. So we'll write negative 1 over m x minus x1, where x1, y1 are specific points and we know the specific point here. So y minus m equal to negative 1 over m x minus negative 1. Alright, so y minus m equal to, let's open this bracket, minus x over m plus, this will plus 1 times negative 1 over m will be negative 1 over m. Okay, so now do we have the equation now with this minus 1 and this can become 1. Okay, so y equal to negative x over m minus 1 over m plus m. So this y, this is the equation of the normal, this is the equation of the curve, and at p and q both of them have common y, right? They have common point. So I can substitute this y by this y. So let me do that. Minus m over x equal to minus x over m minus 1 over m plus m, right? Now let's get rid of the denominators now, because we have m here, x here. Let's multiply the whole equation by mx so that the denominators are gone. Mx multiplied by minus m over x, x and x will cancel out. We'll be left with minus m square. Okay, this here m and m will get cancelled out. X times x will be minus x square. Here same way m and m cancels out, so minus x. Okay, and then m and m square x. So let's make them a quadratic equation, collecting everything to the left side, which will be x square plus x minus m square x, and then we have minus m square already here. I can see something, we can factor this and solve it very easily, but I'm not going to do that. Maybe in exam scenario you may not know. Let me do that one first and then let me tell you what I'm trying to say. So here, here it is x, if I take common, x plus 1, and minus m square if I take common here, x plus 1 equal to 0. So x plus 1 and this will be x minus m square, right? So we get two answers. Here this will give us x equal to negative 1, which we already know at p, x is equal to negative 1, and this will give us x equal to m square, which will be the x coordinate of q. But I want to teach you something which is, because in exam scenarios sometimes we don't get a sense how do we do this. So I'm going to do it different way now. So let me undo these things first and rewrite it. This is x square. Then we have x and x both here, so we can write plus 1 minus m square x. Take an x common from the both. Minus m square equal to 0. This becomes a quadratic equation, and we know there are two answers for this. So that means we have to use quadratic formula. And we'll use quadratic formula, which is complicated, much more complicated than what we did just now. But I'm going to challenge myself and I'm going to tell you that nothing is impossible. So what is the quadratic formula? It says minus b plus minus square root b square minus 4ac over 2a, right? And that's what we're going to do. So this is b minus 1 minus m square plus minus 1 minus m square minus 4 times 1 times minus m square over 2 times 1. That is the 1. So minus 1 plus m square plus minus. If I square this, I will use the same expansion I've been using in this exam. A minus b square is a square plus b square minus 2ab. So that will be a square, which is 1 square in this case, 1. Then m square square will be m to the power 4 minus 2ab, 2 times 1 times m square, 2m square. This will be, this is negative, so positive 4m square over 2. So minus 1 plus m square plus minus. Now minus 2m square plus 2m square will be positive 2m square, right? So if you see 1 plus m square plus 2m square is again the square, perfect square of 1 plus m square square. If you look at these three by this format, a plus b square equal to a square plus b square plus 2ab. So cancel this square and square. So what are we left with? Divided by 2. It is minus 1 plus m square plus 1 plus m square once, and minus 1 plus m square minus 1 minus m square once. This plus will keep it the same, 1 plus m square, and this negative will change the sign of the both. And now we spent more time on this, I know, but if there is no way out, you can use this way, otherwise the one I told you earlier. So minus 1 and 1 cancel, 2m square over 2, and here we get m square and minus m square cancel, and minus 1 will be minus 2 over 2. So x equal to 2 and 2 cancel, m square. X equal to this and this cancel, minus 1, which we got in previous method also. So this one was already the x coordinate of P. This will be the x coordinate of Q. So we got the x coordinate. Let's find the y coordinate by using the formula y equal to minus m over x. This was the equation of the curve, and Q lies on this, so we can use y equal to negative m over m square. M and m square cancel, negative 1 over m. So the coordinates of the second point Q, P was already known to us, are m square, this one, and minus 1 over m y part. I hope you understand this method as well. Thank you very much for watching this video. Please subscribe to my channel and like this video, share with your friends. Thank you very much.